Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1. And we are going to solve a question number 7, which belongs to paper 9709/51 for the session May June 24. Let's see what question number 7 says. It says the 8 digits 1, 2, 2, 3, 4, 4, 4, 5 are arranged in a line. Question number 8 says how many different arrangements are there of these 8 digits? We all are well versed with the concept that whenever question asks for arrangements, we apply the concept of permutation. So this question is not exceptional to that concept that we will have to find the number of arrangements. So let's start applying the concept of permutation. So number of arrangements number of arrangements number of arrangements is equal to, we know that we are going to apply the concept of permutation. So there are total 8 digits. That means there will be 8 factorial, and along with that we know that if there are any identical digits or alphabets or whatever, if there is something identical, in case of arrangements we just divide the total arrangements by the identical digits. So here two twos are identical, so 2 times 2 factorial, we will divide by 2 factorial. Again there are 3 fours are also identical, so 3 times 3 factorial will divide this. Now if we use our calculator, it will show 8 factorial over 2 factorial divided to 2 factorial into 3 factorial. So total number of arrangements is 3360. This is one of the easiest of all solutions, because we know that simply for arrangements we apply the concept of permutation. Let's move on to the immediate next question. The immediate next question says find the number of different arrangements of the 8 digits in which there is a 2 at the beginning, a 2 at the end, and the 3 R's are not all together. So there is a little twist in the question, that there is a 2 at the beginning, a2 at the end, that's all right. But whenever they ask for 4 hours, fours are not all together. That means it's a very complicated concept. Fours are not all together. All together means all 3 fours cannot be together, but there can be 2 fours together. So it is a little bit complicated. That's why always we think vice versa. Let us find the number of arrangements considering the twos at the end and at the beginning. So what will we write? We will write, let us write that number of arrangements. Suppose there is a 2 at the beginning. Okay. So this is 1, 2, 3, 4, 5, 6, 7, 8. 2 is at the beginning and another 2 is at the end. Then we will write number of arrangements, and there we are not applying any more restrictions in this case. Number of arrangements, number of arrangements when a 2 a2 at each end. We are just considering 2 leaving fours together. We will solve that part in the next step. Each end, each end. So what is the case? The case is total number of arrangement is, look at this, as 2 have already been arranged. So what is our duty? We will just arrange all these 6 letters, isn't it? So it is going to be equal to 6 factorial. These 6 letters will be arranged in 6 factorial ways. Among them, we know that 4s are identical. How many 4s are there? 3 4s. So there will be 3 factorial, and ultimately the number of arrangement is going to be 6 factorial, means 720. If 720 is divided by 3 factorial, means 6. So 720 divided by 6 means actually 120. So this is only one part of the solution, not the final part. For the final part, we are going to write this again. Look at this. If 2's are at each end, so 1 2 3 4 5 6 7 8, 2's are at each end, and we will see that if fours are, look at this 1 4 2 4 and 3 fours, if all these 3 fours are together, then what will happen? Look at this. Now how many spaces are there for inter arrangement? This is one. Look at this one space, two space, and three space. So 3 factorial, as well as these one can also exchange its position. So total how many arrangements can be possible? Let us write number of arrangements, when of number of arrangements when fours are fours are together. Fours are together. If fours are together, then what will be the number of arrangements? Equal to, as we have seen the scenario, if fours are together, then these two have already been arranged. Now only these, in between these two, we will arrange. How many spaces are there? It will be considered to be one unit. This one is actually one unit. All fours are together, so it is one unit. One unit, two units, three unit, four units. So total there are 4 units, and there is no question of identical because all fours are behaving like one unit. So it's 4 factorial, and 2 we don't need to bother about. 2's are already arranged, so it's nothing but 4 factorial. Equal to 4 factorial means 24. Now we are moving on to our final answer. Our final answer is number of arrangements, number of arrangements, number of arrangements when a 2 is at each end, end and fours are not all together equal to. So what will be the number of arrangements when a2 is at each end? So first part of the solution is when twos were at each end. Look at this. When twos were at each end, number of arrangement was 120. Look at this. This is 120. So we will write 120, and from that, if we leave all fours together, if we arrange all the digits keeping all four together, then the number of arrangement is going to be 24. So just we will subtract this 24. If we subtract 24 from 120, there will be only 96, which is the number of all arrangements. Answer is 96. Now you may raise a question, why did we undergo the complication of 3 different arrangements? Actually, there is a little twist in the question, as I have told at the beginning. Whenever they ask for arrangement when the digits or letters are not all together, in that case it is very long concept. Look, fours are not all together means all 3 fours may not be all together, but there may be 2 fours together. So we will have to undergo a long solution if we think from that viewpoint. So the easy option left for us is what we will do vice versa, opposite to that. We will see, first step we will see if twos are at each end. If twos are at each end, then we have got that there are 120 arrangements. Then they have told not all fours together, all together. Then if what happens, if we get that all fours are together, if all fours are together, we got that 24 is the number of arrangements. So if we want to get the negative answer, that means not all fours together, just we did the subtraction from total number of arrangement. If we subtract 24, I mean when fours are together, definitely we will get when fours are not all together. Actually this is vice versa. We They told us to find not all fours together, we found all four together. So the number of arrangements when all fours are together, if we subtract this, then we will get that the remaining arrangement is for not all four together. So let's move on to the immediate next question. The question number C says, question number C says, sorry, the digits are selected at random. Digits are selected at random from the 8 digits 1, 2, 2, 3, 4, 4, 4, 5. Find the probability that 3 digits are all different. So it's a very clear and precise that they have selected the digits. So it's no more a concept of permutation. For selection, we always choose combination formula. So let's see what are the scenario. They have told that all three digits should be different. If all three digits are different, there is no, let it be written two. There are two twos. There are three fours, and the rest three digits left are 1, 1, 3 as well as 5. Okay, these are the left digit. Let me write them using comma. 1, 3 as well as 5. 3 and 5. Okay, so if we choose two digits, from two digit we'll have to choose one digit, and we may choose one digit from 4 and another digit from these three. Or the second possible case may be we may choose nothing from first pair, and from the second group we may choose one, and from the third group we will have to choose two, because these all three are different. So from here we can choose any number of digits. Then we can choose what may be the third possible case. We may choose nothing from here, nothing from here, and all three from here, because all three are different here. Then what will happen, if we choose one from here, one from here, and nothing from 4, and from the third group we can choose these two. So these are the four possible cases for this solution. I hope you got my points. They have told that the digits should be different, all different. So for all different, if we, these are the possible cases, we may choose one from each of the group, or we may choose all three from this last three, because the first two groups are containing identical letters. So these are the possible cases. So what will be the number of selection? For selection, we have already come to know that for selection we apply the combination formula. So let's write from 2. If we choose 2, 1 from the first group, it is 2 choose 1, into from the second group also we are choosing 1, from 3 we are choosing 1, 3 choose 1, and from the next 3 also we are choosing 1, 1. Then equal to, what is it going to be? Okay, let me write just beside this, not over here. Let me erase this. Okay, for the first case, from two digits we are choosing one, two choose one, into again three choose one, into the third case is among three digits we are choosing one. So what will it be? Two choose one means actually two. You know how to uh, find this number using your calculator also you can do. And three choose from three digits, if we choose one, then three ways it can be chosen. Then if we choose one digit from three, again it is three. So total number of selection is going to be 18. Well, then the second case is from 2 we are choosing nothing. 2 choose 0, and from 3 fours we are choosing 1, and then from 3 digits we are choosing again 2. 3 choose 2. So what is it going to be? 2 choose 0 means actually there is only one way we can select, and 3 choose, so 1, and 3 choose 1 is nothing but 3, and 3 choose 2 is also 3, because from 3 digits if we choose or picks, if we pick up 2 digits, then 3 ways we can pick them up. And you know how to apply the combination formula. So what is it going to be? It is going to be 9. Then the third case, what is the third case? Third case is from first two digits we are choosing nothing, so 2 c 0, into from second three digits again we are choosing nothing. Then for the third group we are choosing all three, so 3 choose 3 means if we choose nothing from 2 it is 1, and we choose nothing from 3 again it is 1, and from three digits if we choose 3, that is actually also 1. It is then nothing but 1. Then the fourth and the last possible case is from 2 we are choosing 1. We are choosing 1, and second group from 3 we are choosing nothing, and from third group among 3 we are choosing 2. So what will it be? 2 choose 1 means 2, and 3 choose 0 means nothing but 1, and 3 choose 2 is actually 3, so it is going to be actually 6. So total number of arrangement, not arrangement, selection is going to be what? Total number of selection is nothing but, if we sum up, it's going to be 6 7 7 9 16, so 34, it is going to be 34. Look, this is the selection of all three digits, different digits. Okay, they have told us to select all three digits differently, so 34 ways we can select them. But that is not the final question. Look, they have told us to find the probability. This is the final answer, probability. So before finding probability, we should know how many selections are there in total. So we will have to write that number of total selections, number of number of total selection selection. Okay, total number of selection, there are how many digits are there? We know that there are 8 digits. From 8 we will choose select only 3. And remember, in the previous solution to question number A and B, we were very careful about the identical digits while doing the arrangements. But remember, in selection actually there is no question of arrangements. That's why whether the digits are identical or non-identical, in case of selection it doesn't matter. So remember, this is the fundamental difference between the combination and permutation formula. In permutation formula, it applies when arrangement matters. As it is nothing but arrangement, this is just selection, so we won't bother about the identical digits. So 8 choose 3 is actually what? It is going to be 8 factorial over 3 factorial, and 8 minus 5 is 5 factorial. 8 minus 3, 5 factorial. So total number of selection is 8 factorial over 3 factorial into 5 factorial, that is 56. So total number of selection is 56. Now we will find the probability. Okay, our probability is going to be Let's write the probability. So probability is equal to, hence our probability, you know how to find the probability. That means required selection will be divided by the total selection. Required selection is 34 and total number of selection was 56. So if we divide 34 by 56, it is going to be 0.607. 0.607. I think you have understood how to find or how to select the particular number of digits or letters from the given scenario. So thank you for all for watching the video, and let's solve the next questions from the next paper. Fi amanillah.